Okay, let's talk. The long way to do this question is to do it like the Babylonians did it. So we ignore the minus 16, but we've got x squared plus 4x, which essentially is x here, and then I might do a little dotted line. This is x, and this is 4. And what the Babylonians said is actually we want to turn this into a square. So we want to make this a bit longer, and actually we want to make it a bit shorter here. And in fact, we can cut this bit off. And how can we make it the same length? Well, we can take 2 from here, so I'm just left with 2, and I can move it over here. I've essentially cut that bit out and moved it here. So I've still got x squared here. I've still got 2x. I've still got a 2x here, so I've got x squared plus 4x. And the only issue is that I don't have that bit there. I don't have that 2 squared bit, which is 4. So essentially, I can write down that x squared plus 4x minus 16, well, let's focus on the first bit. X squared plus 4x is actually equal to this square, x plus 2 squared, but then I'm going to have to minus 2 squared or minus 4 from it. And therefore, finally, if I want to minus the 16 as well, then it's going to be x plus 2 squared minus 20. The quick way of doing this question, once you've understood things like this, is that you basically have the 4 to give us the 2, and then you minus that thing squared, so minus 4 in this case. You still need to minus the 16, that's where the minus 20 comes from, and that's how you can complete the square quickly. But actually, looking at it geometrically and getting your head around it can really help. Now we want to solve this equation. Give your answers in surd form as simply as possible. Okay, this is actually basically saying use part A to help you out here. We can just set x plus 2 squared minus 20 equal to 0. We can rearrange it to x plus 2 squared equals 20. We can take a square root of both sides, which is root 20, but it's plus or minus root 20. We can then write x equals minus 2 plus and minus, and then we try to simplify this surd, which is root 4 root 5. We find the largest square number that goes into 20, so finally we get minus 2 plus or minus 2 root 5, and that's as simple as it gets. Now, you can use the quadratic formula instead, but I think there's going to be still quite a lot of manipulation to do. Actually, I might just have a little look at it below to see how. I shouldn't have put a minus in there, sorry. So it's minus 2 plus or minus 2 root 5, but then my actual answer is minus 2 root 5, or minus 2 plus 2 root 5. If we were to use the quadratic formula, then it would be b squared, slightly minus 4 plus or minus b squared minus 4 times 1 times minus 16, all square rooted, divided by 2, and you would get to the same answer. You just have maybe this is a bit nicer. You can use the quadratic formula for this question, non-calculator. So that's 16 times 4 is going to be 64, plus 16, we're going to get plus or minus root 80, divided by 2. That's going to be minus 2 plus or minus the square root of 80 over 4, basically divided by root 4 instead. And then I get to the same kind of place. It's going to be minus 2 plus or minus root 20, and I would have to simplify the surd. So I do think this way is quicker, and it's really nice to show that you can solve an equation by completing the square. But at the end of the day, you can use the quadratic formula if you want. Finally, sketch this graph, clearly showing the coordinates of any turning points. That's the key bit here. So once you have something in completed square form, let me write it in completed square form again. It's x plus 2. So you could do part 2 if you can't do part 1 actually by using the quadratic formula. However, you have to, well, you don't have to, but typically you use completing the square to be able to get the turning point. And the turning point, well, we can see that this thing is always squared, so it's always positive or 0. So this whole thing is always greater or equal to minus 20. It can't be any less than that, because this thing itself is always greater or equal to 0. The question is, when is it equal to 20? When this thing equals 0, so it's when x is 2. So the turning point is when x is 2 and y is minus 20. And that's really all this question wants. We put in x equals 2 and minus 20 down here. I'd be tempted to add some other coordinates on, so we see that it passes through the axis at 16. We've got some roots in surd form, so these are where it crosses the axes. I don't think the question wants it in that much detail. It basically wants the general shape of the quadratic, and it wants you to label the turning point. So there we go, that's what it looks like.